Alright, we're working on 1.3 vocab cards. This is going to be video 1 of 2. I'm going to split it into 2 just so the videos aren't too long. Now, the first word is parallel lines. The majority of y'all know what a parallel line is. The definition is lines that are lying in the same plane and not intersecting. Okay, so we know parallel lines never intersect. They run in the same direction. So what that looks like for your picture. So we're going to have two lines. They don't have to be a certain distance apart from each other as long as they're in the same plane and running in the same direction. Okay, so they could be as close as this, or as far apart as this, or even farther apart. I'm going to just fit them both in this box right here. Now, to actually know for sure that these are parallel, they would need to be marked, and the marking we use for parallel is similar to the one for congruent. Congruent, you use tick marks. For parallel, we use little arrows. Okay, so if you have an arrow on each of these, that means they're running in the same direction, they're parallel. Okay, you could use more than one arrow. If I had 2 arrows, the parallel line would need 2 arrows. Okay, those are the markings for parallel. I'm going to put a couple of points on here so that we can name these lines, and I can show you a parallel statement. So we'll just say AB and XY. Okay, so the statement would read line AB, and remember we name a line with 2 letters and the line symbol above it, is parallel to. This is the symbol for parallel. Notice I highlighted the double L in the word because that's really what the symbol looks like. It's just 2 slanted L's. Okay, so line AB is parallel to line XY. Okay, and that would be your parallel statement. For an example, if you want to try another, if you are asked to draw ray AB parallel to segment CD, you could start with either one of these. It doesn't have to be the first one or the second one, any order. I'm going to start with ray AB just because it's listed first. So I have ray AB, and I have to identify it by naming it. Notice the ray, the first letter is the endpoint, so this has to be A, and this could be B. And then I have a segment CD. Remember, a segment has 2 endpoints, no arrows, and it doesn't have to be a certain length as long as it runs the same direction. Okay, and a segment is named with both its endpoints, so this would be C and D. Okay, I am not done though because I have not marked it. If you turned something in and it didn't have the markings, I would count it wrong because these are just 2 lines that appear to be parallel, but I don't know it unless they are marked. You have to get used to using your geometric markings. So until I put these arrows on there, labeling them as parallel, you're not done. Alright, the next one is perpendicular. Perpendicular is pretty much the opposite of parallel. These are 2 lines in the same plane that do intersect, and they intersect at a 90-degree angle. It can be lines, rays, or line segments. I'm just going to use 2 line segments because that's the tool I have open already. So if I have a line segment and another that intersect, creating a 90-degree angle, okay, that's perpendicular. There's no symbols to put on the lines, just this box symbol that goes at the intersection in the angle. All 4 of these angles would be 90 degrees, but you don't need to label all of them with the box. 1 is sufficient. Okay, so I'm going to label these points so that I can write the statement for you. So let's just go with L, M, N, O. So you could write that segment OM is perpendicular to, and this is the symbol for perpendicular, it's an upside down capital T. Hopefully that's easy to remember because you can see it's a 90-degree angle created here. So segment OM is perpendicular to segment LN. That's exactly how you would write it. In the example box, we can put a problem where you are asked to draw line HK perpendicular to ray HY. Okay, notice they both have H, so they're going to have that common point. So I'm going to start with line HK. I have to put points on there to label H and K. Now if I have a ray HY, the first letter is H, and the first letter in the name of array is the endpoint. So I have an endpoint coming off this point H. I'm sorry, a ray coming off point H. And it has to make a 90-degree angle, but I could go straight up or straight down. It doesn't matter, it doesn't specify. So I'm just going to come down. Okay, but it does tell me it's called HY, so I would need to pick a point on here and label it Y. And again, I am not done until I have it with its geometric markings. Okay, for perpendicular, remember it's the box. Okay, so this line HK forms a 90-degree angle with ray HY. Alright, the next one is skew lines. Skew lines are lines that are not in the same plane. Parallel and perpendicular were in the same plane. Skew is not. They do not intersect, but they are also not parallel. Okay, they're not intersecting because they're on different planes. The best way I know to depict this is with a cube or a box. Okay, so if you can draw a box here, and I do this just by drawing a square and then overlapping a second square, starting in the center of that first one. And then you connect the four corners. Okay, this gives me 6 different planes. Each side of the box can represent a different plane. So if I have this left plane over here, I have 4 different lines in that plane. So I'm going to choose one. I'm just going to choose this back line. Okay, so I have this red line in this left plane. Okay, if I look at the front of the box, this is a different plane. And I could have a line. I'm going to choose this bottom one in the front plane. So now I have 2 lines in 2 different planes that will never intersect. If you were to continue drawing these, it may look like they would intersect right here, but that's because it's flat on a piece of paper that we're looking at it. If you can visualize it in 3 dimensions, like this box, this red line would be behind the green line. They wouldn't actually ever touch, and that's because they're in different planes, and that's what skew lines are. For an example, if you wanted to depict it another way, we talked about representing planes with parallelograms. So you could draw 2 different parallelograms to represent 2 different planes. Now we name planes, if you would remember, with a capital cursive letter. So I could name this first plane M and the second L. So if I have 2 different planes with a line in each that are not parallel, so they're not running in the same direction. Oh, that wasn't long enough. There we go. Okay, those lines are not parallel, but they will never intersect because they are not in the same plane. Hopefully that makes sense. We can talk about it tomorrow or Monday in class if you have questions. Alright, I'm going to stop this video here. This is the end of 3.1 Part 1. Make sure you watch Part 2 also, because we've got a few more note cards to do. Okay, so this 3 note cards on the first video,